Now the fifth question for you is, 2 moles of a perfect gas undergoes 3 following processes. A reversible isobaric expansion from 1 atmospheric pressure 20 liters to 1 atmospheric pressure 40 liters. The second one, a reversible isochoric change from 1 atmospheric pressure 40 liters to 0.5 atmospheric pressure 40 liters. The third one, C, is a reversible isothermal compression from 0.5 atmospheric pressure 40 liters to 1 atmospheric pressure 20 liters. Now you have 3 parts for this question. The first one is to draw a PV diagram. The second one to calculate total work and total heat change in the above process. And the third one, calculate change in enthalpy, entropy and internal energy for the overall process. Sandeep will help us with the problem.
Fine. See, in this question they gave us 2 moles of perfect gas that is undergoing 3 different processes. So in first part they asked us to draw PV diagram. So what are the different processes that the gas is undergoing? First one is reversible isobaric expansion.
Correct.
What is isobaric?
Pressure constant.
Yeah, exactly. Here also same thing. It is from 1 atmosphere 20 liters to 1 atmosphere 40 liters, right?
Correct.
So mark it at 1 atmosphere 20 liters to 40 liters.
Right.
Right. Isobaric expansion.
A straight line.
Exactly.
Parallel to V.
And in second process, it is an isochoric change, implies constant volume at 40 liters.
Right.
It is decreasing pressure from 1 atm to 0.5 atm. Right. So 1, 40 to 0.5, 40.
Right.
Right. And in the third one they gave it as reversible isothermal compression. So
Correct.
in isothermal process temperature is constant and it is going from 0.5 atm 40 liters to 1 atm 20 liters. Right.
Right.
Here it is 0.5 40 to 1 atm 20 liters.
Yeah.
Isothermal process, in the sense it is an ideal gas phase, PV equal to nRT.
Correct.
Right. PV is constant.
Yes.
It will be like xy equal to constant graph.
Yeah.
It will be somewhat like hyperbola.
Yeah.
Right.
Correct.
So this is the PV diagram. First one is isobaric,
Right.
second one is isochoric process, and third one is isothermal process.
Okay, so the first part of the question is done.
Exactly.
That's
And
how your PV diagram looks.
coming to second part of the question, they asked us to find total work done and total heat change in the above process. They asked us about total work in the process, right?
Right.
In 1, 2, 3 and the third step. Right. First one is isobaric step. Second one is isochoric step.
Right.
And third one is isothermal step.
Hmm.
Right. Work done will be sum of works in these 3 cases.
Exactly. Yeah.
Right. What is work done in isobaric process? It is
Delta PV.
exactly P delta V, since pressure is constant, right? P into delta V. Fine.
Right.
So pressure is 1 atmosphere into change in volume 20 to 40, right? 20 liters.
This will be your W1.
Exactly. So W1 it will be 20. And coming to isochoric process, what is work done in isochoric process?
20 liters ATM.
Isochoric process at constant volume, in the sense work done is 0, right?
Right.
See, work done is always the area between the area under PV graph.
Yeah.
Right.
And for that particular path, the area will be 0.
Exactly. Area will be 0. So work done is 0. Right. And in the third case, isothermal process. So work done is, we have a formula, right? nRT ln V2 by V1.
Yeah.
This is W3, right? This is W2. Fine. Here they give in our question they gave 2 moles, but we don't know the temperature, right? But we know for any gas PV equal to nRT, ideal gas.
Yeah.
So replace it by PV into ln V2 by V1.
Right.
We know product PV it is 20 into ln final volume it is 40 and initial it is 20. Right. So it will be 20 ln 2.
Correct.
So total work will be W1 plus W2 plus W3. It is equal to 20 plus 0 plus 20 ln 2.
Right.
Fine. This is the total work that is done in the process.
Okay. And the unit being liters atmospheric pressure.
Exactly. See, here check the sign convention. In the first process, system is increasing volume, right?
Yeah.
It is work done by the system. So work done by the system is always negative. So this should be minus 20, not positive. And in third case, system is decreasing volume from 40 to 20, right? So work is done on the system. So this is positive. So be careful with the sign convention. So this is minus 20 plus 20 ln 2.
Right.
So we'll get it as 6.14 atmospheres.
6.14 liters atmosphere.
Liter atmosphere, exactly.
That's right. Now the third part.
Coming to the third part, they asked us to calculate change in internal energy, change in enthalpy and change in entropy for the cyclic process.
Right.
See, we know from the basic definition that internal energy, enthalpy and entropy, these three are state functions.
State functions, yeah.
So what does it imply?
That doesn't depend on the path.
Doesn't depend on the path,
Yeah.
right?
And
So
since they come back to the same point.
yeah, finally we are coming to the same point, 1 atmosphere and 20 liters, right? So change will be 0.
Right.
So delta H or delta U and delta S, it will be 0.
All will be 0. Guys, it's time for us to take up the question number 6. Question number 6 says, for an ideal gas, consider only PV work is going from initial state X to final state Z. The final state Z can be reached by either of the two paths that are shown in this figure. Which of the following are correct? You have 4 options. You have to say which are correct, and there can be more than one correct answers.
Fine. While solving these kind of questions, look at this graph, and we need to analyze this graph and check the options.
Right.
See, they asked us to find change in entropy and work done in different paths, right?
Right.
See, go for first option. They asked us delta S, change in entropy from X to Z, right?
Right.
What is entropy? It is a state function or path function?
It's a state function.
State function, exactly. It doesn't depend upon the path, right?
Correct.
Fine. So they are asking from change in entropy from X to Z.
Right.
Since entropy is a state function, we know that change from X to Y plus entropy change from Y to Z plus entropy change from Z to X. This one will be 0, right?
Right.
Since we are reaching from X back to X, again back to X.
Correct.
So this total change will be 0.
Right.
In the sense, delta S from X to Y plus delta S from Y to Z, it will be equal to delta S from Z to X minus of.
Right.
Right. This one equal to delta S of X to Z.
Correct.
Right. And
Reverse
this is our
process.
first option.
Right.
So first option is right.
Okay.
And coming to option B, they are asking work from X to Z. right? So work done, it is a path function or state function?
Path function.
Path function. So
Right.
it depends upon the path, right? So they're asking from x to z.
Correct.
See, this is x and this is z.
Mm-hmm.
So we know that if given PV diagram, work done, it is area under PV graph, right?
Correct.
So from which state to which state you are going, see the area under it,
Okay.
right? So from x to z, so work done will be under this one area,
Right.
right? So
Yeah, this will be work from x to z.
yeah, so this will be the work done, right? From x to z. They gave that work done from x to z, it is equal to x to y plus y to z. But what is work done from x to y? Area under
This
total
whole
graph.
yeah.
So it will cover everything, right?
Yeah.
So which is not equal to this one,
Right.
right? So
Clearly,
option B
yes.
is wrong.
Hmm.
So coming to option C, work done from x to y and y to z, right? So work done from x to y and y to z,
Right.
x to y and y to z. See, x to y, it is an isobaric process, right?
Right.
Constant pressure.
Yeah.
And y to z, it is an isochoric process.
Mm-hmm.
And area covered by this y z line, this is 0, right?
Right.
Since work done in isochoric process is 0.
Exactly.
So work done from x to y and y to z, it is only equal to work done from x to y,
Right. Right.
right? So
Mhm.
option C is right.
Okay.
Since work done from y to z, it is 0.
Right. Right.
Okay. And coming to option D, they asked us change in entropy from x to y and y to z, right? X to y and y to z. And see here, this is not a cyclic process.
Right.
They didn't mention here from z to x, right?
Uh-huh.
So this is not a cyclic process. Remember
Uh-huh.
this thing.
Right. Right.
So you will be confused while solving problems. We think this as a cyclic process. This is not a cyclic process here, right? So x to y and y to z. This is not equal to x to y, right? Since we need to add both entropies. Here
Right.
we are neglecting entropy from y to z.
So delta S from x to y to z would be sum of the entropies from x to
X to
y
y
and then
and
from
y
y
to
to z.
z.
Yeah.
Entropy from y to z, it is not equal to 0,
Correct.
as it happened in work,
Yeah.
right? So remember this thing. So here option A and option C are right.
Okay, and B and D are wrong. So guys, we'll move on to the next question now. Okay, it's time for us to have a look at the seventh question now, which says, from the following data, calculate the enthalpy change for combustion of the cyclopropane at 298 kelvins. The enthalpy of the formation of carbon dioxide, water and propene are minus 393.5, minus 285.8 and 20.42 kilojoules per mole respectively. The enthalpy of isomerization of cyclopropane to propene is minus 33.0 kilojoule per mole. Is that correct?
Fine. See, again this is totally a thermochemistry question,
Right.
right? See, here they asked us to find combustion of cyclopropane, right?
Right.
Enthalpy change for combustion of cyclopropane.
Hmm.
So while solving thermochemistry questions, first check what we need to find.
Right.
So they asked us combustion of cyclopropane. So what is combustion? Cyclopropane plus oxygen.
Correct.
Burned in presence of oxygen, we get carbon dioxide plus water. This is not balanced. I'm just writing the equation, right? And then check for the information what they gave.
Right.
Right. See, here they gave enthalpy of formation of carbon dioxide, water and propane. And they gave enthalpy of isomerization of cyclopropane to propene is minus 33 kilojoules per mole.
Correct.
Right. So they gave cyclopropane, which is this one, to propene. Right. This one is delta H equal to minus 33 kilojoules per mole.
Right.
Right. And we need to find this one. And they gave enthalpy of formation of carbon dioxide, water and propene. Right. See, here propene when burned in presence of oxygen, we get carbon dioxide plus water.
Correct.
Balance it, here we get 9/2 oxygen.
Hmm.
So why are we doing it exactly? See, in the question they gave enthalpy of formation of carbon dioxide, water and propane.
Right.
Right. And here, if we add these two equations,
Hmm.
1 and 2, we'll get this third equation.
Right.
Cyclopropane plus oxygen gives propane gets cancelled here,
Right.
carbon dioxide plus water.
Hmm.
So I wrote this equation.
Right.
Right. So while solving any problems by using Hessler, just do some algebraic methods. Right.
Correct.
So for equation 2,
Hmm.
we need to get delta H, right? We know equation for equation 1.
Hmm.
Change in enthalpy for equation 3 is delta H1 plus delta H2 by
Right.
Hessler. Right. We know delta H1.
Hmm.
We need to find delta H2.
Correct.
And again by Hessler, we know that change in enthalpy for equation 2, it is enthalpy of formation of products minus enthalpy of formation of reactants. Right?
Correct. Yeah.
So, what is enthalpy of formation of products? So, enthalpy of formation of carbon dioxide minus water. 3 into delta H of formation of carbon dioxide, delta H of formation of water minus of reactants now.
Right.
Delta H of formation of propene plus delta H of formation of oxygen. Right?
Into 9/2.
Exactly. Into 9/2. So,
Right.
don't do these kind of mistakes. We usually
Correct.
commit these kind of mistakes here. Fine. Next, see. They gave us delta H of formation of carbon dioxide and water.
Hmm.
Right. So 3 into 393.5 plus 285.8. Right.
Right.
And for propene they gave it as 20.42.
Correct.
Right.
Hmm.
See here, they gave enthalpies of formation as negative terms, right? Minus 393 and minus 285.
Hmm.
So these are negative. Total. Right. So
Right.
see, and usually while solving problems, we take enthalpy of formation of water as 0. Sorry, oxygen
Oxygen is 0. Okay.
So remember this thing. While of cyclopropane. Right.
Correct. Correct.
Yeah. Cyclopropane to propane they gave it.
Yeah.
Yeah, and we found this one.
Correct.
Right.
Correct.
So remember one thing, while solving any question using Hessler, see, just start with the equation what we need to find,
Correct.
right? And then check, see the equations what they gave,
Right.
and do some algebraic methods and try
To get to the final question.
Get to the final question,
Uh,
right? And
Right.
this is the key thing that we need to do while solving any question on Hessler.
okay, that makes sense. We'll move on to the next question now. Guys, let's ask Sandeep to help us solve this question, which is the 8th question here. The difference between heats of reaction at constant pressure and constant volume for the reaction. Now the given reaction is 2C6H6 in liquid form plus 15 oxygen gives 12 CO2 plus 6H2O at 25 centigrades. So what is the difference between heats of reaction at constant pressure and constant volume for this reaction in kilojoules per mole, right?
Yes. See, just don't get confused with the question means here. Heat
Right.
of reaction at constant pressure and constant volume.
Hmm.
Don't get confused. See, start with the equation what you know.
Right.
What is the equation that you know for heat of reaction? Means delta Q.
It's delta U plus delta W.
Exactly. So delta Q equal to delta U plus delta W.
The first law, right?
First law of thermodynamics. Exactly. But they asked us to find difference between heat of reaction at constant pressure and constant volume.
Right.
So we need to know what is heat of reaction at constant pressure
Right.
and what is heat of reaction at constant volume.
Hmm.
Right. See. heat of reaction at constant pressure.
Right.
We termed it as enthalpy. Remember,
Yeah.
H equal to U plus PV.
Correct.
As we discussed in theory, many of the reactions we do it in open vessels, that is at constant pressure, right?
Right.
So, especially for heat of reaction at constant pressure, we termed it as enthalpy.
Right.
So, which is H.
Correct.
So, delta H change in enthalpy here equal to delta U plus delta of PV, right? And now we need to know heat of reaction at constant volume, right?
Right.
Since delta Q equal to delta U plus delta W,
Right.
but at constant volume, what is delta W?
V delta P.
Delta P, which is equal to 0, right? Since volume is constant.
Yeah.
So this is 0, right? So delta Q equal to delta U,
Right.
right? So heat of reaction at constant volume, it is equal to change in internal energy,
Right.
and heat of reaction at constant pressure, it is delta U and delta of PV,
Right.
right? So they are asking us to find heat of reaction at constant pressure minus heat of reaction at constant volume, right? Which is equal to delta H minus delta U.
Right.
Makes sense? Since this one is delta U, right?
Correct.
So which is equal to delta of PV. And see, come to the given question. Everything here they gave it as in this reaction
Mm-hmm.
delta PV, we can replace it by delta of nRT, right?
Right.
What is delta N? It is change in moles of gases.
Correct.
Don't consider liquids or solids here,
Mm-hmm.
right? So delta H minus delta U equal to delta of PV equal to delta N into RT, right? So what is delta N? Only change in mole of gases, right?
Right.
So in products we have 12 moles of gases,
Right.
and in reactants only oxygen is gas, right?
Yeah.
So 15 moles of gases.
Right.
So delta N will be 12 minus 15,
Right.
right? And
Mhm.
into R. R is 8.314, which is in
Mm.
joules, right? Kilojoules.
Yeah.
Into 298. That is the temperature what they gave in the question.
Right. In kelvins.
In
Yeah.
Kelvin, yes. So this one will give us minus 7.43 kilojoules per mole.
Right.
See, in this question, what we need to know is that what is heat of reaction at constant volume,
Right.
and what is heat of reaction at constant pressure.
Hmm.
So start with the equations what you know,
Right.
and check at constant pressure and constant volume, and
And try to simplify it from there.
exactly.
Okay. So guys, you saw how we tried to simplify the problem from there, and we reached a very simple formula which was delta nRT that helped us solve the question. Now we'll move on to the next question and see what happens there.